Now in this video we will discuss about the second inner transition series or actinoids. So actinoids, or is also called the second inner transition series or 5F series. Why they are called 5F series? Because their 5F orbitals are getting filled. Now what are actinoids? Actinium followed by 14 elements whose 5F orbitals are getting filled is called actinoids, or other name for actinoids is actinides or actinons, or they are also called the second inner transition series or second inner transition elements. Now actinium is in period number 7 and group number 3. So this 5F series comes from group number 3 and period number 7. Actinium followed by 14 elements. So the first element of actinoid is thorium with atomic number 90. So thorium, atomic number 90, and the last element is lawrencium with atomic number 103. This is the first and last element of actinoid. Now next let's see the electronic configuration of actinoids. The general electronic configuration of actinoids is radon 5F1 to 14 6D0 or 1 7S2. Now atomic number 89 is actinium and the configuration is radon 6D1 7S2. Now thorium is the first element of actinoid with configuration radon 6D2 7S2. Now next comes americium and configuration is radon 5F7 6D0 7S2. 96 is curium, radon 5F7 6D1 7S2. 103 lawrencium with configuration radon 5F14 6D1 7S2. Now the oxidation state, again the common oxidation state exhibited by actinoids is +3, same like lanthanoids. So the common oxidation state is +3. Other than +3, they can show +4, +5, +6, etc. Now you can see the electronic configuration of americium and lawrencium. They have taken this configuration to get extra stability due to half filled and completely filled orbital, and also the curium, that is Cm, is half filled to get extra stability due to half filled f orbital. Now oxidation state is +3, they take +4, +5, +6 and +7. Now unlike lanthanoids, these actinoids show a large number of oxidation state. Why? This is because of small energy gap between the orbitals are 5s, 6d and 7s subshells. So all their electrons can participate in bone formation. So actinoids can show a wide range of oxidation state due to small energy gap between the orbitals 5f, 6d and 7s. Now same like lanthanoid contraction, we have something called actinoid contraction. Actinoid contraction. And what do you mean by actinoid contraction? Actinoid contraction is a regular decrease in the size of actinoids with increasing atomic number, and the reason for this actinoid contraction is due to poor shielding effect of 5f electrons. So as a result of this poor shielding, the atomic radii decreases steadily across the series. Next is the properties of actinoids. Actinoid ions are colored because of FF transition. Many of the actinoid ions are colored due to FF transition, and the color can be shown only by the elements which has unpaired electrons in 5f orbital. Now they are paramagnetic in nature and all the elements are radioactive. Now they are highly electropositive and form salt as well as complexes. Next is the use of actinoids. Thorium is used in the treatment of cancer and in incandescent gas mantles. Uranium is used in glass industry, textile industry, in medicine and as a nuclear fuel. Plutonium is used in atomic reactors and in atomic bombs. Next, let us see the differences between lanthanoids and actinoids. The first difference is lanthanoids and actinoids. So, this is a board question. Differentiate between lanthanoids and actinoids. Now, the first difference is lanthanoids, besides +3 oxidation state, they can show +2 and +4. Whereas actinoids, besides +3 oxidation state, they can show +4, +5, +6 and +7 oxidation state also. And you know the reason for this. Now, the next difference is this lanthanoids has less tendency towards complex formation, whereas actinoids has greater tendency for complex formation. Now, the next difference is lanthanoid compounds are less basic, whereas actinoid compounds are more basic. Now, difference number 4 is lanthanoids do not form oxocation, whereas actinoids, they form oxocation. And example for oxocation is UO2 2+, then plutonium ion PuO2 2+. Now, the next difference is, now except promethium, lanthanoids except promethium, they are all non-radioactive. So, among the lanthanoids, the only radioactive element is promethium. Okay, this is radioactive. Whereas in actinoids, they are all radioactive. Now, the next difference is the magnetic properties can be explained easily, whereas here the magnetic properties are complex. So, these are the 6 differences between lanthanoids and actinoids. Now, we have questions. The first question is, actinoid contraction is greater from element to element than lanthanoid contraction. So, when you compare lanthanoid and actinoid contraction, the actinoid contraction is greater. That is due to poor shielding effect by 5f electrons in the actinoids than that by 4f electrons in the lanthanoids. Now, the next question is, decide which of the given atomic numbers are members of inner transition elements. So, few atomic numbers are given and the atomic numbers are 29, 59, 74, 95, 102, 104. Now, you have to decide which are the inner transition elements. Now, you know inner transition elements means we have lanthanoids and actinoids. Lanthanoids, you know the atomic number, it starts from 58 to 71, and actinoids, atomic number is from 90 to 103. So, the elements, that is 59, inner transition elements are 59, then we have 95 and 102. These 3 are the inner transition elements. The question is to identify the inner transition elements. Now, next question is to write the electronic configuration of elements with atomic number 61. Z is equal to 61. 61 is promethium PM. Its electronic configuration is xenon. This is the lanthanoid. Xenon 4f5, 5d0, 6s2. Next is atomic number 91. Atomic number 91 is protactium. Protactium, symbol is Pa. with configuration. The configuration of protactinium is radon. It's an actinoid. 5F2, 6D1, 7S2. Now the last one is atomic number 101. The element is mendelevium with symbol Md, and mendelevium is also an actinoid, so its electronic configuration is radon, 5F13, 6D0, 7S2. Now we have one last question, that is the chemistry of actinoids is not so smooth as that of lanthanoids. Justify by giving example from oxidation state of elements. We know that the lanthanoids show limited number of oxidation state, that is +2, +3, +4, because of large energy gap between the 4F and 5D subshells. But actinoids show +3, +4, +5, +6, +7 due to small energy difference between 5F, 6D and 7S subshells. So with this we complete the actinoids of the second inner transition series. Thank you.